Hello and welcome to part 9 of the UBIK solution. We're going to have a look at how to create a simple shoulder rotation, getting its input from the head and also getting some input from the hands. This is going to be a simple solution to begin with, and we're going to circle back to this problem here later on. But for now I just want to address this first, so we have something that sort of works, and then we can discuss the edge cases and sort of extreme handling later on. So inside our UBIK component here, we want to return back to the set shoulder function here. And if you recall from, I think it was the last video, we set at just a shoulder rotation from the yaw that came all the way from the head. Now this is actually sort of okay, and to be honest, I don't think I'm going to touch this part of it today. But just to make note of it, this is a contribution that comes from the head. Let's see. This is a head rotation in component space, by the way. So I'm just going to copy this over here. And I think what I'm going to do is to collapse this into a separate function. We'll call this get shoulder rotation from head. And let's make that pure, so it's a little bit more compact. Okay, and the other part is going to come from the hands. And we're going to have a look at how the hands contribute to the rotation. Actually, let's go ahead and open up the, not that one. Let's go into, no, wait a second. We're just going to, it's mentioned in the thesis paper by Matthias Pache, but simply stated, it's just a matter of getting I'm just going to draw this. Getting a, if we assume that or perceive the head here from above, and then we have the shoulders or the upper arms here. Then we have an elbow joint somewhere along, let's just draw it actually. And this is going to be the lower arm left, and this is going to be the lower arm right. So somewhere around here we're going to have a hand and we're going to have another hand. So we're going to have a hand left and a hand right, like this. So what the logic is going to, how the logic is going to work is by, if you recall, we created this shoulder joint, which is below the head, sort of. Actually, I'm going to draw it a little bit back because that is kind of where it is situated, just a little bit back. And what we're going to try to do here is to calculate the vector, or we're going to find the vector that goes from that shoulder joint to the left hand and the shoulder direction to the right hand. If we add these two vectors up, the resulting vector is going to be something, if I can draw this, it's going to be, if I just pick another color here, let's check a green one, that's not green. The resulting vector is going to be looking like this. And this is another sort of approximation that you can use for positioning the shoulder rotation. And remember again, we're only looking at the yaw, so don't worry about the roll or the pitch at this point here. So if we go back into the code, the way we would program this or set this up was to say, well, we have the shoulder location here in component space. We just calculated that. And so that means that we can, from this point here, we can draw out a vector minus another vector. And as you can see, this is in component space, so we need another location in component space. So let's get the left hand here and split this open and then subtract that. Then we have the other one, like this, just with the right hand. So these two vectors here, this vector we have here and this one is what corresponds to this vector here and this vector here. So what we now need to do is to add these two together. Like this. And this is going to give us the resulting vector, which is going to be this one here, the green one. And then what we want to do is to get a rotation in the end here. And let me just check something. Yeah, you know, we can do a since the hands and the shoulder, they are not going to be in the same plane, so these vectors here, they are actually going to be pointing up and down, and you can't really see it at this point, but what we need to do is to isolate just the planar contribution here. So what I'm going to do here is I'm going to break this vector here, and then I'm going to make a new vector. And depending on whether or not this is what you really want, you can do this, or you can ignore it. It gives some different results, definitely. But as you can see now, I'm just ignoring the C part here, and this is what I'm going to use. So only in the X and the Y. In order to get the angle, we can use a built-in function called a tang in degrees. And then we can split this part here open, and then the X goes to X and the Y goes to Y, like this. And this is going to give us an angle, which we can use as the yaw contribution. So if we type in make rotator, like this, and we plug that in, and we can basically just use this one up here as the rotator. Oops. As you can see now, it's following the X, or the left hand direction. It's not taking any effect for the on the right. We forgot to normalize. Great. So we need to normalize this one also. Yeah, normalize here. So before you break this and isolate the X and the Y, then normalize it. I believe it makes a little bit of a difference if you normalize these two individually. I don't recall, to be honest, if it makes a big difference or not. If we just look at this from the top, we can see what it does a little bit more easy. So if we these are the hands, sort of. So if you if I'm having my hands, can we see my hands? If my hands are pointing in the same direction like this, you can see my shoulder frame is kind of pointing in the same direction. If I move one of my hands out to the side, what will naturally happen is that my chest is going to follow a little bit along with the right hand, but it's definitely not going to stay at the same place. So what this is compared to is when I move my hand to the right here, you can see how the chest moves according to that. So it's going to balance itself kind of in the middle here. This does have some drawbacks, as you can see here, when we hit some extremes here, but as I mentioned in the beginning of this video, we're not going to worry too much about that at this moment here. Also, I am noticing that it seems like some of these are rotated backwards. It's kind of weird. Maybe it's just because, no. I might have made a mistake because they seem to be pointing backwards, these joints here. I think actually they should be pointing the other way. I will address this in a later video if I figure out what it's supposed to do, but for now I just want to make a mental note of it and leave it as it is. So anyway, now we have a different way of adding in a chest contribution here. But that means that now that when we turn our head, it's not really moving. It's just turning around a little bit, but it's not rotating. So as you can see here, when I'm rotating my head now, the actual rotation of this joint here is not moving. It's only moving when I move the hands, as you can see. So one way we can change this a little bit, and this is what I actually ended up doing in the end, was to take a blend between these two. So lerp, and then take one part into B and the other part into A. And for now, let's just give it 0.5. And I don't know if this is needed, but anyway, let's just check it off anyway. And this is going to give us a kind of a wrong rotation to begin with, it seems. But as you can see, it is rotating when I move my hands. And when I rotate my head, it is also rotating. But as I mentioned, currently it's moving in the... it seems to be wrong. Let's see. Do I need to check this one off? Let's see. What am I missing here? Okay, shoulder rotation from the head. So this is giving us a yaw directly forward. And we do have seem to have a bug. Okay, what I'm going to do here to begin with is I'm going to take this part here. I'm going to take actually this part here, and I'm going to convert this into a function, so it's just a little bit more manageable. So now we get it's going to create a bit of a mess here. So let's move this out of the way a little bit. Like this. And A is going to be the... What was A? I forget. A was the shoulder, and that is A2 also. So this one is the same. So A2 is going to come from A. And A2 we can just ignore now. Okay, so this is the shoulder. And this is going to be the left hand. And well, basically, actually what we could do is just to leave them, because they are like variables that we have access to outside this function, but nevertheless it's a bit more clear this way. Okay, so now we have one going one way and one going the other way, and we are returning a rotation here. And let's make it pure also and give it a proper name. So get shoulder rotation from hands. Okay. So I'm gonna, for now, because I need to debug this, I'm gonna set this to directly from the get shoulder rotation from hands out to the shoulder, and I'm gonna see what direction it's gonna point. And it seems like, to me, like it's sort of pointing too much to the side. Let's see, top. Maybe it's just the way I have them placed. This and sort of here. Copy and paste. What? That was not unintended. Let's see if I can move this over here. Okay, so now it's straight. That's good. And that probably means that the shoulder, let's see. And if I take this part here, it's pointing here. Okay, so now I get it. Okay. Maybe you already figured this out. This needs to go, I think, the opposite way. Let's see, what did I do here? I'm just connecting, connecting the shoulder to hand again. Okay, so this is wrong now, and I need to reverse the other one maybe also. So the shoulder is at the top. Shoulder is at the top. So maybe here is at the bottom, so here I probably need to switch it. Is that the right way? Okay, so you can see now the red arrow is pointing forward again. So I think this is that's basically just what I did wrong. Okay, so scratch that mental note since it's now solved. Okay, so this is sorry about that mistake here. This is gonna be probably the what we will continue with. So as I mentioned before I started fiddling with this, now you can see when I rotate my head, the upper body also rotates, and also when I rotate or move my hands, come on. You can see this has an effect also on the upper body as well. So now we have contribution both from the head, when I turn my head from side to side, but also when I'm moving my chest or my hands like this. Okay, so sorry about that, it got a bit messy. I'm gonna just jump into VR and we can have a quick test from it, from inside here before we end this video. Okay, so I'm turning my head. You can see that the shoulders, they are moving. And when I move my hands, they also move. So I'm stretching my hand out and the shoulders, they turn. And the other one. when I stretch both of them out, well, as you can see, this is where I hit an extreme, which I will get back to. But as you can see, when I stretch both my hands out, the chest stays in place. Only when I then start to move my head, you can see it does have a small effect. Okay, so generally this way of solving the shoulder rotation is what I like the best. And that is basically what I had for this video. So just to get an idea of what we're missing in order to say that we have something that is sort of working, what is missing really? Yeah. Well, if let's pick a color, blue. So we are actually mainly just missing this part here. So just the elbow joint, or what is referred to as the lower arm left and lower arm right. So the lower arms. And so this joint here is really what we are missing. And we're gonna begin to have a look at that in the next video. It's a bit complicated, I guess. It's sort of the most complicated part of this this algorithm here. So I'm most probably gonna split this up into two. Mainly because there's a bit of a theory I want to cover first, and also because there's a basic version, and then we also have some contribution coming from the hand rotation before we actually get to the point where we can start to try and put this onto an actual skeleton. So anyway, that's quite a few videos out. So I guess 10 videos out or something, I would say. Time will show. I haven't recorded them yet, so I have no idea. Anyway, thank you for watching, guys, and see you in the next. Bye.